These are the notes for 4.7. They are located as part of your notes for 4.6. Just scroll down and you'll find them. It talks about isosceles and equilateral triangles. So we talked about these when we were looking at our proofs. There's the base angle theorem. And the base angle theorem talks about, let me draw another triangle. Given that you have an isosceles triangle because the lengths of the sides, A, B, and AC are shown to be congruent or equal in length, we then can say that the angles across from these sides, so angle B and angle C, are congruent. So this is the base angle theorem. You need to include this in your notes cards. That given AB is congruent to AC, then angle B is congruent to angle C. Now the converse of this, which you also want to know, says given that these angles are congruent, then we can say that AB and BC are congruent. So given angle A is congruent to angle C, then AB is congruent to CB. And this is the converse of the base angle theorem. And so you want to include both of these in your spiral note cards. It's really helpful to know. And we were using these on our proof worksheet, even though we formally didn't. Even though we formally didn't go over these. This last one talks about the fact that we're dealing with an equilateral triangle. So given the fact that you have three sides or three angles that are shown, you can infer that the sides are the same. So this is just a corollary. Let me think. Corollary to the base angle theorem. You don't have to put this in your notebook, but it's nice to know. So basically, given angle B is congruent to angle A, which is congruent to angle C, then AB is congruent to AC, which is congruent to BC. So basically, it's just saying that if you've got three angles that are congruent, you have an isosceles triangle, equilateral triangle. If you have an equilateral triangle, well, then you know that all the side lengths are the same. Why do we need this? Well, so we can do problems like this. All right? We are given here that these two sides are the same. And so looking at that, we would say, well, this is the base angle theorem that we're going to use. And basically, the base angle theorem says, given these two sides are congruent, therefore x plus 7 equals 55. These are angle measures. That tells me that x is equal to 55 minus 7, which is 48. Now, so x is 48. What is y? Well, we're going to have 55 plus 55 plus y equals 180. And so we get 110 plus y equals 180. So y is 70 degrees. So I don't have a degree sign on x because x is part of the degrees already, but I need the degree symbol on y because it's a value. All right, here we go again. This one's a little more difficult and tricky. Notice that angle, angle, angle. You're going to want to ask me, are these angles or are these side lengths? You're going to have to look at the markings because I won't tell you. All right, so we have to think about how we want to solve these. We're going to look at two separate triangles. They're each isosceles. Triangle 1 is isosceles. Triangle 2 is isosceles. They share a common side, but that doesn't mean that the angles are going to be the same. Okay? So what we realize that is this is 50, this angle, and this angle are congruent. And so we can say twice 2y plus 64 plus 50 equals 180. So 4y plus 128 equals what? 130. 4y is equal to 2, so y is 1/2. So if y is 1/2, that makes each of these 65 degrees. I'm just plugging it in. All right, so we have to remember that we need to work our way inside a triangle. So we have a linear pair here. If this is 65 on the right, then this little part, which I didn't say I needed to know, but sometimes you have to find extra information. This side is going to be 180 minus 65, which is 115 degrees. Why does that help me? Well, because I have an isosceles triangle on the left side. Again, I'm using my base angle theorems. These two sides are congruent, therefore this angle, which is labeled to be 45 minus x over 4, and this one, which again I don't really need, are congruent. So we're going to set 45 plus, or excuse me, minus x over 4. We're going to multiply that by 2 because there's two of them. We're going to add 115 degrees, and we're going to set it equal to 180. And so we're going to say 90 minus x over 2, because I'm distributing, is equal to 65 degrees. Gosh, guess what we could have used also? Couldn't we have used the exterior angle theorem? If this is 65, and the remote interior angles equals the exterior angle of 65. So there's more than one way to work these problems out. I'm going to get, by moving the 90, that negative x over 2 is equal to negative 25. So positive x over 2 equals positive 25, and x is equal to 50. So what was I trying to find? I was trying to find x and y. I found both of them. I'm done. Okay, here we go again. The question is, are we dealing with angles or are we dealing with sides? I see no angle markings. That tells me that these are side lengths. This side length is y plus 12. This side length is 3x squared minus 32. And over here I have 5y minus 4. Notice that this is an isosceles triangle, and on the left and on the right I have an equilateral triangle. Well, that means that every side in this triangle is 5y minus 4. Now it's this side here that's connected to both the triangle has two ways to name it, either 3x squared minus 32 or 5y minus 4. But to figure out my y, it's easier to look at this side as 5y minus 4 because this, again, is an isosceles triangle, which means that y plus 12 equals 5y minus 4. So 4y is equal to 16, and y is equal to 4. Well, then we can go back to the first triangle and say, well, gosh, that means 3x squared minus 32 is equal to 5y minus 4, but y is 4, so 3x squared minus 32 is equal to 20 minus 4. 3x squared minus 32 is equal to 16. I'm just doing some math here. 3x squared is equal to, what is that, 48. X squared is equal to 16, and x is equal to, careful, taking the square root in an equation, a plus and minus 4. Well, we look to see, do they both make sense? Positive 4 works because it gives me positive answers for my sides, but the negative 4, oh wait, positive and negative 4 will work because I'm squaring them. So this answer for x has two answers. Okay, is that it? That's it. Good luck on your homework.